we listen.
Why do they talk and we listen? It's because they're smart and we're dumb. How do I know that?
That's very easy. Because if I define a technical civilization as one able to communicate, that is, one with sophisticated radio-astronomical technology, we have become such a civilization only in the last few decades. Well, it is very unlikely that there is any other civilization that has also reached this plateau of radio technology in the last few decades. Either they are further behind us than that, in which case they don't have radio telescopes, in which case they can't talk to us, so to heck with them, or they are much further beyond us, ahead of us, in which case they are the smart guys and we are the dumb guys. So I don't see any escape from the conclusion that there is no technical civilization in the galaxy able to communicate and as dumb as we. Now, if the nearest civilization is a few hundred light years away, do we have the technological capability to communicate with such a civilization? The answer is yes. In fact, we have a technological capability vastly in excess of what is needed to make such a search. If I can have the next slide. This is a photograph of the world's largest radio and radar telescope, the Arecibo radio telescope, run by Cornell University. Now, if the nearest civilization is a few hundred light years away, do we have the technological capability to communicate with such a civilization? The answer is yes. In fact, we have a technological capability vastly in excess of what is needed to make such a search. If I can have the next slide. This is a photograph of the world's largest radio and radar telescope, the Arecibo radio telescope, run by Cornell University for the National Science Foundation. It's in Puerto Rico. And there are various impressive numbers about how each pylon is larger than the Washington Monument and all that. But it's 1,000 feet across. But let me ask this question. Suppose this Arecibo telescope were in radio communication with another identical telescope. That is not the creations of a civilization much more advanced than we, but someone exactly at our level of technological advance. And we move those two radio telescopes further and further apart. How far apart are they when they can just barely make each other out? The answer is that they can be anywhere in the Milky Way galaxy and still talk to each other. Now, of course, the communication time scale will be quite long. They're at opposite ends of the Milky Way galaxy. It takes 100,000 years for the message to go one way. But what this indicates is that we have a capability vastly in excess of what we have actually used. The next slide is a lovely night photograph of the great cage holding the feed horns at Arecibo. If there are 1 million technical civilizations in the galaxy, that means that 1 out of every few 100,000 stars on the average should have such a civilization. That means that we have to look at a few 100,000 stars before we have a leg up on the problem. We have to date only looked at a few hundred stars. So we have done less than 0.1% of the effort to check the problem out. Now, the Arecibo telescope is not needed for this problem, because there are dozens of radio telescopes which would be adequate for that. So what we have is a kind of maybe failure of the imagination, or possibly failure of nerve. But I think that is changing. There are a lot of signs that radio astronomers in many countries, but particularly the United States and the Soviet Union, are prepared now to muster a serious, long-term, rigorous search for radio messages being sent our way. And the content of such messages can only be guessed at. But the critical point is that were we to get such a message, it has to be from someone who knows he is communicating, lights please, with a civilization much more backward than he. And he has to want, he or she or it, to communicate with those dumb guys. Also, by definition, the civilization has to have solved its problems of dealing with technology for the simple reason that it's around. It did not destroy itself. It seems to me that there is an enormous amount that we have to learn from such a set of messages. There are some who think that the translation problem will be hopeless. Many of us think that the answer is just the opposite, that the problem of interstellar communication is not cryptography in the military sense of making a message so difficult that nobody can understand it, but anti-cryptography in the sense of making a message so easy that anyone can understand it. And there are several suggestions about how to create such messages, the simplest being you send pictures, and pictures in a way that anyone can understand that they are pictures. And such messages seem extremely likely. And so what you'd imagine is, coming through this room at this moment, there may well be such messages. Whiffling through the girders of a great radio telescope at this moment, there may be such messages. And they would contain what? They would be the primer. So you don't have to wait till the beginning of the message to understand how to read it. And then, with less regularity, the actual message in some language which I will call galactic, and containing no one knows what, maybe the equivalent of the Encyclopedia Galactica. I think there's no question that such an event, even before the translation of the message, would have a profound and, I believe, benevolent effect on human history. I think we are living in quite remarkable times. As I said at the beginning, this is the first moment in the history of the world when we can approach such questions. What are the other planets like? Are they inhabited? Is there intelligent life on planets of other stars? If we were alive 100 years ago, let's say, and we're interested in such questions, we could speculate, but there's nothing we could do about it because we did not have the tools. Were we alive 100 years from now, we would not be doing the speculating because we would already know the answers. We would be taught it in grammar school. So if our objective is to start out ignorant and wind up knowing the answers to these major problems, I think there is no time in the whole history of the world better to be alive in than now. Thank you.
Dr. Sagan will take some questions.
Okay, Okay, maybe I better put on my glasses because I can hardly resolve the people on the fourth balcony. Okay, who has a question in a loud voice simultaneously? Okay. I'll try to repeat the question so everybody can hear.
Could there be another form of communication from another planet besides radio messages?
Could there be another form of communication from another planet besides radio messages? That's it?
Beyond our technology?
Beyond our technology. Well, you're saying, can I imagine something that I know nothing about? And the answer is no, by definition. On the other hand, I would be the last person to exclude such a possibility. I mean, what's the chance that by accident, the moment we're alive and talking about this problem, we have found out all the laws of nature and invented the last machine that will ever be invented? I think it's very likely that in the 23rd century there will be new discoveries in physics and new technological inventions, and there'll be new fields of knowledge that we don't even have names for today. And surely there may be methods of communication then that we don't know about now. However, as far as we understand the way the world is put together, you cannot travel faster than the speed of light. And so the light time propagation limitations I talked about seem to be real and I would say permanent. That doesn't exclude, for example, interstellar spaceflight because of what is called time dilation. Namely, your clock slows down as you go close to the speed of light. And so if you want to get from here to some other place, let's say the center of the galaxy, in a human lifetime, you can do it. The only trouble is that you got to travel very close to the speed of light, which is beyond our present engineering capabilities, but may well be possible in another century or two. And then the other awkward aspect is that when you come back from that trip, the Earth will be 60,000 years older and all your friends will have aged. Yes? In the gravitational perturbation method that I talked about for detecting other planets, does it have to be one big heavy guy of Jovian mass, or could it be a lot of little tiny planets of, say, terrestrial mass? It has to be one or more big guys of Jovian mass. And the point is that the little guys don't go all around the star together. The inner ones go faster, the outer ones go slower, and so they're not in phase. So they don't all tug in the same direction at the same time. So it's only a big tug that will do it, and for that you need a big planet. Yes? Do I believe in anything mentioned in Chariots of the Gods? No, not a single thing. Let me say a word about it today. Today I was at an airport and there was a woman next to me talking to a friend of hers. She said, "Oh, Chariots of the Gods, you ought to read that. I hear it's very good, all that Roman stuff." For those of you who have been in Antarctica for the last 5 years, there is a book called Chariots of the Gods, ? Although the question mark tends to be left out, by a Swiss named Erich von Däniken, who has the following kind of argument. He looks at the monumental architecture, wall paintings, and ancient technology of man, and any time he can't figure out how the locals constructed it, he deduces that extraterrestrial intervention was necessary. Since von Däniken can figure out almost nothing, he has extraterrestrial intervention all over the planet. And He does have a nice set of archaeological reminiscences, but they have all, without exception to my knowledge, been solved before von Daniken wrote his book by the archaeologists. I mean, is it possible that 5 generations of Egyptologists never asked themselves, hey, how were those pyramids built? Is it possible the archaeologists never wondered about the method of construction? Well, it's well known, not to von Daniken, but to archaeologists. It's understandable how you can slide a 20-ton rectangular parallelepiped, how you can float it down the Nile, how you can transport it, and what's more, written in Egyptian hieroglyphics on these blocks are things like, we moved it, Tiger Team 11. Now I ask you, is this a likely inscription by a superior extraterrestrial civilization? Also, to take another example, he talks about the beautiful, they're lovely, stone monoliths on Easter Island. You know these great set of guys sort of from the shoulders up, all standing in the sand, looking out to sea, and they got these haunting faces, and it makes, great black and white photography at sunset and stuff. So there's the same kind of argument. Von Daniken looks at them and says, pretty heavy. Says, the quarries are up there. These big statues are down here. I can't lift it. So it is impossible for anyone to move it. And he quotes Thor Heyerdahl's book Aku Aku about Easter Island. Now, by accident, I had read Aku Aku. And in Aku Aku, Heyerdahl describes how he and 2 Easter Islanders moved one of these great stone monoliths and made it stand up. How do you make it stand up? The thing weighs 20 tons. You shove little rocks under it, and it gradually creeps up, like that. So, Chariots of the Gods is a monument to the credulity of readers and to the greed of publishers. And the most ominous aspect of it is that so many people, 40 million copies have been sold worldwide, is that so many people consider this to be a good book. In fact, I think it is a superb book for any university-level logic course because it has a higher density of different logical errors per page than any book I know. It should be required reading, but not for the usual reasons. Why is it so popular? I think it's clear. This is a book which speaks to largely unvoiced religious needs. It is about, well, it's clear, the title says it, Chariots of the Gods, in a secular age when the traditional religions have mostly been discredited, with some exceptions, but certainly the general trend is away from traditional religions. Here is the idea that the gods exist. They're benevolent, they're all-powerful, they live in the sky, and what's more, they're not all that mysterious. It's just a higher technology than our own. It is old-time religion dressed up in the clothing of modern science, and that speaks to a very real human need. But I think where we badly want to believe something, that's where we have to be especially careful in accepting arguments. If I present you with a contention on the hyperfine structure of the spectrum of the vanadium atom, I assume there are no powerful passions on this issue. But if I present you with an argument about God's coming to the earth, that's something where there are powerful passions, and that's where rigorous scrutiny of every step in the argument is required. And, well, von Daniken hardly requires rigorous scrutiny, just superficial scrutiny is enough to see that his arguments are no good, but something else like some of the flying saucer reports, that's a case where You want to carefully examine every link in the chain of evidence, and there also, to my regret, I can find no cases whatever in which something interesting is reliably reported. Well, I'm sorry to have spent so much time on answering that one question. Please. Six or seven what? Stone discs? Uh-huh. Well, the question has to do with a claim that in 1938 in China, in a cave, a set of artifacts that, quote, could not possibly have come from the Earth, close quote, were found. 700 discs. Well, I would simply say, you know, what I would ask for the scientific journal in which these results are published. I have not heard of them. Never heard of it. And I suspect, yeah. Named what? What's the name of the book? Anthony Lawton. Uh-huh. That's a British mechanical engineer, not an astronomer. You see, I would ask, you know, this is just I don't know anything about this, but I would ask a few simple questions. What is the result of neutron activation analysis of the samples, which will give you the precise proportions of all of the chemical elements in it, and you can see whether it is of terrestrial manufacture or not. I would ask you for X-ray fluorescence studies, for gamma ray spectroscopy. I mean, all of that can easily be done. With 706 disks, then we certainly can examine one of them to great detail. But that hasn't been done, to the best of my knowledge. There are many cases of this sort. There is a claim of a cube of perfect metal, which is removed from an ancient sediment and is said to be residing in the Salzburg, Austria Museum. And it's perfectly machined, and yet is in an old vein of coal. Obviously means that there were machine tools around in the Carboniferous epoch of 300 million years ago or something. Except it turns out that it does not exist, despite the fact that there are dozens of books on it. It does not exist. It is a hoax invented out of whole cloth. So I stress that there are large numbers of books which are written not out of a passionate love of the truth, but out of a passionate love of the prophets. And a book which says we are being visited sells more copies than one that says, I don't know if we are. I mean, that's hardly news. Say, the book, we're not being visited, or I don't know. Well, who thought we did know? But a book that says I have some new evidence, that sells. And as a result, there are strong pressures, which both authors and publishers know about, for the preferential publication of books which allege to show that we are being visited. But I stress that there are a set of very simple routine tests. I mean, there's a vast materials properties facility right here at Ames. It could easily be used to examine any extraterrestrial artifact alleged to be around. To the best of my knowledge, no such artifact, claimed artifact, has ever survived such an examination as anything other than a typical piece of material on the planet Earth. Yeah. It's certainly technologically, I guess everybody heard that question. It's certainly technologically possible, because it's even technologically possible right now. Whether it will actually occur is quite another question. I think manned lunar bases are not the most efficient use of a very limited number of dollars available for science. And that's, I don't know, tens of billions of dollars worth of effort. And I personally think that there are more important things to spend such large amounts of money on, but I'm not in any expert position to tell what the country will be doing in another 15 years, so I don't know. Yeah. Okay, first question, I'll try to answer them one at a time. So, what is the power level at Arecibo to communicate across the galaxy? Well, you also got to ask what is the bandpass, okay, because both of them go together. But calculation I referred to was for something like 100 hertz bandpass and a megawatt transmitter power. Next question. What wavelength? There are a number of natural frequencies, only a few, which happen to live in the minimum in the galactic background noise. And 21 centimeters is the one obvious one because it's the hydrogen hyperfine transition. There are a few others. Psychological impact of the receipt of a message. Well, I would say that the first important consequence would be the message, independent of its content. I mean, the fact that someone is sending us a message which has intelligent content to it is, I think, an enormously important fact in human history. It ends what I would call a 4 billion year long isolation from the rest of the cosmos, which us Earth beasts have had. I think it will have the most salutary social consequences because the differences among the people on the Earth are going to be insignificant compared to the differences between us and anybody else. That's the clear consequence of Darwinian evolution. Even if you started the Earth out again and let only random factors operate, you would never wind up with something closely similar, most evolutionary biologists believe, to a human being. You might wind up with an organism with comparable moral and intellectual and artistic and other faculties. But we are the product of a winding, tortuous, unsure, and I would say irreproducible evolutionary pathway. Well, the discovery of other beings elsewhere who are not even vaguely human, I think makes human beings something especially precious. And I think that preciousness is only appreciated in circumstances where you see that there are alternatives. And I would make the statement even broader. We are, us human beings, essentially identical to all the beasts and vegetables. I mean, on the insides, all those other organisms on the Earth are the same as us. It's just on the outside that there are certain superficial differences, but I mean, it's the same nucleic acids, the same proteins, the same genetic code, the same code book for translating one kind of language into another. And so I can imagine that the first consequence of receiving such a message would be the unification of the Earth. And that seems to me something that is desperately needed. And then, of course, there is the actual content of the message, whatever that is, but that depends on the content. Yeah. How many missions to Mars in what sense? What is actually planned? Well, I mean, the next one is Viking, which I mentioned, which has cameras, chemistry, biology, seismometry to listen for Mars quakes, has a meteorology package to see the weather on Mars. In 1976, your evening news report may well tell you what the weather report is in a place on Mars called Chryse. And then the orbiter itself has a range of instruments, including cameras, to look at the surface. The next step beyond Viking, next logical step from my point of view, is a Viking rover. Again, an unmanned vehicle like Viking, but on tractor treads, which can then walk over the Martian landscape. And so we can today decide where to go tomorrow. Everybody can take a look at the environment and say, see that strange purple hill over there, and that's where we're going tomorrow. That's just looking a little bit into the future. The full range of future Martian exploration is impossible to predict because it depends on what we find. Yeah. Yes. The criterion a radio signal would have to have in order to be a message. Well, unambiguous, I would say. And I can give you a simple example of an unambiguous message, unambiguously intelligent message. The first 30 prime numbers. Okay? There's no way that a natural object is going to send out beeps which miss all the factorizable numbers and say only the prime numbers. So that's a simple example. There are many others. The repetition of a signal array, which is the product of two prime numbers, and which, when you make it up as x rows of y columns, you see a picture. Okay, that's pretty unambiguous. So there are certainly such cases. There may be ambiguous cases, but there are lots of unambiguous cases. Yes, all the way back. How soon to pick up such a signal? Well, it depends on how seriously we pursue the task. If we don't look, we're not going to find. To look at hundreds of thousands of stars, which I think is the minimum effort required unless we're very lucky, takes decades. And so it's not that you go to the radio telescope for a week and you have the answer. It's a sustained effort taking decades, and probably cooperative endeavors of scientists in many countries carve out different regions of the sky and so on. Yeah. My opinion of Dr. Alan Hynek? He's fine. Something more detailed you'd like? Question his integrity? No, I don't question his integrity. No. I mean, we can differ on conclusions, but I do not question his integrity. Yeah. radio messages out? Well, you can't quite make out what Clara Bell says on the Howdy Doody show, but that the message is of vaguely intelligent origin should be clear, despite the inverse square attenuation of such signals. Even today, we could pick up our level of commercial television broadcasting from the nearest stars. And so a more sophisticated civilization could pick it up from much greater distances. So I think there is such a message propagating out, containing all of the early 1950s television programming. I mean, containing, you know, Howdy Doody and Milton Berle and the Army McCarthy hearings and other signs of high intelligence on the planet Earth. Okay, other questions? Yeah. That's my understanding also. Yeah. Oh, this recently reported finding is merely that there is a galaxy with an enormous volume of gas around it, which in lateral dimensions makes it the biggest galaxy that's known. You can't see it that big, but if your eyes were good at the radio part of the spectrum, then you would see it that big. And, you know, we're always going to find new and bigger things if we look long enough. A young man in a pink shirt. I have seen many UFOs, and I'm happy to say that most of them had the U removed after I examined them more closely. I'll give you a case if you like. Once at Harvard, I was giving a popular lecture to a much smaller audience than this, kind of along these lines, and I said similar skeptical things about UFOs when asked. And then walking out, there are in Massachusetts, but I guess not here, policemen in all public gatherings to protect the audience from the speaker or something. And there's two Cambridge policemen were standing outside the entrance doing this thing, you know, talking to each other. So I came out and I looked, and sure enough, there was this light, eerie, bright, hovering, slowly moving. So what was it? I couldn't tell. So I went home and got a pair of binoculars. Oh, but I got to tell you, before, on the way home, I stopped by in a restaurant that some friends of mine owned, and I said to them, and then they said to the other people in the restaurant, said, hey, there's a UFO up in the sky, you got to come out. And everybody thought it was terrific. They rushed out, the cooks rushed out, and people with napkins still on the, you know, hanging. Oh, terrific, look at that. Wow, maybe we're being visited, intelligent beings from somewhere else. What do you suppose they look like? How many light years away? Very animated, exciting discussion. Walked home, got my binoculars, came back. Through the binoculars, you could see that the one light was resolved into two bright lights. And then as outriggers, you could see little red and green light, and they were blinking on and off. And then you could make out, when the lights got especially bright, as in the thing came near you, there was a faint droning noise that you could hear from the sky. And I guessed, and it later turned out that that was right, that it was a NASA weather airplane, which shines a bright light down to see about how far the light goes. It measures the scattering particles in the atmosphere. When I explained this to my friends in the restaurant, the reaction was disappointment. Not delight at finding out what it was, but disappointment at it not being a space visitor from somewhere else. And that's very easy to understand, because is this a memorable story? hello, dear, you'll never guess what. I was having lunch in a restaurant, dinner in a restaurant, and a guy came along and showed us something in the sky. I thought it was a UFO, but it was an airplane. Okay? That's a nothing story. But suppose instead it didn't have that last part of it. We don't know what it is. Maybe it's a visitor from somewhere else. It's much more exciting. Well, I've found that that kind of thing is a lot of the motivation for the excitement which keeps the UFO thing going. I guess I'll answer a couple more questions. All the way in the back? Those aren't the only two. The question is, which theory of the origin of the universe do I subscribe to? The steady state theory says that the universe did not begin, that it is eternal, and that matter is being made from nothing all the time to replace the matter lost by the expansion of the universe. And when you ask where does all that matter come from that's being made all the time, the answer is from the same place that all the matter in the Big Bang cosmology gets made from, except slower. Now you can see that the steady state or continuous creation, as it was called, model predicts that the universe should be the same in all times and places. But when we examine the most distant objects, we find that things out there are not the same as things around here. That, for example, there seems to be a horizon in time before there were galaxies. We can see so far out, we see a place further back than which the galaxies have not yet been made. So that's powerful evidence against steady state. But I stress that Big Bang is not the only alternative. Big Bang everybody knows about. It's just a slightly updated version of the theory presented in Genesis 1:1. Both a slightly expanded time scale of some 15 billion years. But equally consistent with the data is the so-called oscillating universe, in which the universe expands and contracts forever, was never made, nor is matter being made now. There is no problem of making matter in such a model, because the universe is infinitely old. And some people boggle at that. How can you not have a beginning? But after all, the traditional explanations have the universe made by a being whose origin we do not further inquire into. So you have the same problem in both hypotheses. It's just whether you want to make it one remove further back in time or not. The remarkable thing is that we are able to do observations which can shed light on as profound a question as the origin of the universe. That's a remarkable thing. Okay, who has a really pressing question? Okay, press. Didn't the Russians send some probes to Venus? Yeah. Did they find anything? Yeah. I'll tell you what Venus is like. Venus has a temperature of 900 Fahrenheit. It has a pressure of 90 atmospheres, 90 times more air than here. It's the atmosphere is mostly carbon dioxide, but it has certain quantities of hydrochloric acid, hydrofluoric acid, and sulfuric acid in the atmosphere. The atmosphere is so dense that there's atmospheric refraction which occurs, and scattering, the net result of which is that the entire surface is suffused in a red glow, and you can't see very far away from you. And Venus, in fact, is a dead ringer for the classical description of hell. Okay. It's our next door neighbor, perhaps as a lesson to us. Nobody thought that Venus was a good place for life since about 1960 or so, I would say. But before then, there were lots of speculations on it. And that's the way the cookie crumbles. Turned out not to be so interesting in that sense, but I'm sure that there's a great deal to learn about the solar system from Venus, much more so than if it were a dead ringer for the Earth. Okay, young lady. Question has to do with is it worthwhile to spend so much money on such unmanned space probes as Viking, and what arguments would I use to convince people of this? It's an excellent question. If I can't answer that, I ought not to be out saying that it's a good thing for us to do. Let me try to make this my last question. First of all, let's try to see what kinds of money we're talking about. The total cost of the Viking mission to Mars, which I've briefly described, is about 1/3 of the fiscal year 1970 cost overrun on the anti-ballistic missile system. Now, it's important to understand that it's not the cost of the anti-ballistic missile system, it's the accounting errors in the Department of Defense in guessing how much it's going to cost in 1 year, not the run-out cost of the thing. Okay, and that error is 3 times the cost of Viking. So, compared to some things that we spend our money on, Viking and similar programs are, seems to me, not very expensive. They have the advantage of gainfully employing the same aerospace manufacturers who would otherwise be involved in creating weapons of destruction. Seems to me a good occupational therapy for those guys. That's just a personal remark on my part. Now, the question is, what good is finding out about the other planets? And I think there are several different kinds of good. And they all can be under the rubric perspective. Let me take an example. The weather. There is not very good prediction of the weather. Right? Everybody knows that. And what's more, there are billions of dollars in crop failures because of poor prediction of the weather. Now, why is it that weather prediction is so bad? Is it that meteorologists are stupid? It's not. There are a lot of extremely smart guys in meteorology. It's because weather is complicated. Now, the skill of being a good meteorologist is knowing what things you can neglect in trying to do the calculations. And that's all kind of seat of the pants thing. Now, in that kind of situation in science, where theory is not working so well, the usual procedure is to experiment. And you do an experiment. Nature tells you what the answer is. But in this case, it's a little hard to do experiments. For example, you want to know what the effect of the Earth's rotation is on the weather. So do an experiment. Stop the Earth from rotating, a Joshua experiment. See what the weather is like. Say, okay, that's interesting. Now Earth, go start up again. Well, that's a time-consuming experiment. It's expensive. It has unpleasant social side effects. You wouldn't want to do such an experiment. But by accident, there is next door a planet which has the same mass and the same radius as the Earth, but essentially it does not rotate. It's called Venus. Well, studying the atmospheric circulation on Venus is the way to understand the effect of rotation on the circulation of the Earth. Or, another serious complication is that we have all this condensable water in the Earth's atmosphere, and that greatly complicates the theoretical meteorology, the latent heat released in condensation. Well, how do you do that experiment? Okay, you remove the oceans from the Earth, only for a year, let's say. You see what the circulation is like, and then you bring the oceans back. Well, again, same difficulties, expensive, undesirable. Shipping magnates will be against it. Well, by accident, there is a nearby planet which has the same period of rotation as the Earth, rotates once every 24 hours, has the same inclination of its axis of rotation, about 24 degrees, and it doesn't have any oceans at all. It's called Mars. So by studying the circulation of Mars, you can profoundly improve our understanding of the meteorology on the Earth. Well, that's a set of examples from meteorology about how basic practical sciences back on the Earth can have their powers greatly expanded by improving your perspective by looking at other worlds. I think the same argument applies powerfully to geology, things like earthquake prediction and control, mineral prospecting, and so on, and most powerfully to biology. For the reason I've already alluded to, all the organisms on the Earth are the same kind, and so the poor biologist has only one thing to study, even though he thinks he's studying lots of things. He has no perspective in what's possible. You find the humblest kind of microorganism on Mars, and biology has taken an enormous quantum leap forward. So I believe that for that reason alone, the unmanned exploration of the other planets is extremely cost effective. Then there are other NASA things which are direct applied things, communication satellites, weather satellites, mineral prospecting satellites, Earth resources satellites. Those are obviously of practical benefit. And then the final statement I'd make is that there is, I believe, a deep human need to explore our surroundings that has been responsible for many of the most brilliant and significant achievements of men and women. But the Earth, at this one first moment in history, has now been fully explored. There are no new places to go on the Earth, except possibly for the ocean bottoms. At just this moment, the technology that has homogenized the Earth provides us with the ability to go and examine other places. And I believe that it is of the greatest importance for human beings to have an idea of the existence of other worlds, to then appreciate the significance of this one little delicate blue sphere, so exquisitely sensitive to depredations by man. That kind of perspective, it seems to me, comes cheap at the price. Thank you.